Hi everyone. Today's lab will be about three-phase connections. So there will be three different experiments. The first one will be delta connection in case of balanced system, then star connection in case of balanced system, then the last one will be unbalanced system. So let us start by the first one, which is delta circuit. So I would like to connect this circuit. It has R and L. And R value is equal to 600 and X is equal to 600. And what is needed from this circuit, I would like to fill in this table for unbalanced system, and for balanced system, I would like to fill in this table. So what is needed in case of delta or Y, I would like to measure the line currents, the phase currents, the line voltage, the phase voltage, the voltage across the resistance, the voltage across the inductance, the three-phase power, the three-phase reactive power, the three-phase apparent power, and the power factor. The applied voltage will be approximately 208 in case of line voltage for delta. Let us start showing the connection in case of delta. So I have R, 3R and the 3L. So I would like to connect RL in series, and then I would like to make delta connection. So I will connect this guy to this guy, and I will connect this guy to this guy. They are series, then this guy to this guy. So I have right now three branches. I would like to make delta. Like what I told you during the class time, I will connect start by end. From the second one, start, end by the end one for the second transmission line or the second branch. And also I will connect those. At that time, I have three different phases, this phase and this phase and this phase. Our supply will be connected to those. I don't have neutral here. What I need, I would like to measure line to line voltage. I would like to measure the line current. I would like to measure the phase voltage. So I'm going to connect between those voltmeter, and I would like to measure the current here, which is the phase current. And also I will measure the power. Let us start connecting this circuit. These are the three different resistors, and these are the three different inductors. I adjusted them so that I have 600, 600, 600. So this one is on only and everything else is off. By the same way here, I need 600. So this is off, off, off. So I have RL. The first step for this circuit is to connect this guy to this guy. Then connect this guy to this guy. Then connect this branch to this branch. Right now I have RL, RL, RL. The next step is I would like to connect three, I would like to connect them delta, so I will connect start by end, start by end, and start by end. So I have three wires. This guy will be connected to this, and this guy will be connected to this, and this guy will be connected to this. Start by end, and start by end. Right now, I have a closed loop, and I have three different nodes. So I will connect between these three nodes my power supply. So my power supply will be connected here to this node, and this node, and this one. So this is my power supply. So I will connect this guy to phase A. I will use the fixed RS value, and I will connect this guy to phase B and this guy to phase C. I don't have neutral. So what I have, this guy connected to phase A, this guy connected to phase B, this guy connected to phase C. This is what I'm showing you here in this graph. The next step is to connect a voltmeter to measure the line and a meter to measure the line current. And by the same way, the phase voltage and the phase current. So for connecting voltmeter to measure the line voltage, so I'm going to use the data acquisition system. So between these two, I'm going to connect voltmeter. So this voltmeter is connected in parallel to measure what? To measure line-to-line voltage. So I would like to measure the voltage between, for example, between those, or between those, or between those, or between those. Here, if you try to see, what do you like to measure? You would like to measure the voltage between these 2 points, or between these 2 points, or like here between this and this, or between this and this. It doesn't matter. So what am I going to do right now? I'm going to connect this guy to measure the voltage between, for example, this phase and this phase, or this line and this line. So it is line to line. E1 is line to line voltage. Then I would like to connect a meter to measure what? To measure the current in this line. So this guy is my line. So I would like to connect a meter here. Like what I told you before. This is my wire. And I will put a meter here. So the meter is connected in series, like that. This is my ammeter. So this I1 is measuring the line current, and E1 is measuring the line voltage because it's connected between 2 different lines. Now the next step is to connect a meter here to measure the phase current, and to connect voltmeter across this phase to measure the phase voltage. So I would like to connect the voltmeter here, which is E2, across any phase. Imagine, for example, I will connect it between this point and this point, so across this phase. So I'm going to connect my voltmeter between this guy and this guy. So my voltmeter is connected in parallel across this phase, or I can connect it across this phase, or I can connect it across this phase. It doesn't matter for me. But right now my voltmeter E2 is measuring the phase voltage. The last thing is I would like to connect here a meter to measure the current inside this phase. So what am I going to do is I'm going to change this small wire by longer one to be able to connect, which is this one. And I will connect my ammeter between those. So my ammeter will be connected between this guy and this guy. So I2, which is this current, is measuring the current in this phase. And E2 is measuring the voltage across this phase. E1 is measuring line-to-line voltage, and I1 is measuring line current. The last thing I would like to do is I would like to measure the voltage across this resistor and the voltage across this coil. So I'm going to use 2 voltmeters. The first one is going to measure, which is E3, this guy. Like what you are seeing, this guy is going to measure what? This guy is going to measure the voltage across R. So I'm going to connect this guy in parallel across R. I'm going to repeat the same story. This guy is going to measure the voltage across the coil. So I'm going to connect it here. Again, this guy is E4, it is measuring the voltage across the coil. And this guy is measuring the voltage across the resistor. Now I have everything connected. I'm going back to the data acquisition system to adjust it. Here I have E1. I adjusted it to measure the voltage AC for what? Actually, it is measuring the voltage E1, which is the line voltage. E2 is measuring the phase voltage. I1 is measuring the line current. I2 is measuring the phase current. And here, I adjusted this guy to measure the power. By the way, the power that I'm going to measure, the single phase power, you have to multiply it by 3 to find the 3-phase power. So if I try to change this guy, it will be changed from P to Q or from Q to S. So I will measure all of them by clicking on that. And E3 is measuring the phase voltage across the resistor, and E4 is measuring the phase voltage across the inductor. And this guy is measuring the power factor. I adjusted it. I can do that by right click on this guy and go to meter setting and you choose the power factor, and you can choose between any two. Here I choose it to be between E2 and I2 because E2 and I2 are representing the phase, and E1 and I1 are representing the line, and E3 is representing the phase voltage across the resistor, and E4 is representing the phase voltage across the inductor. Now I'm going to turn on my switch, and then I'm going to see the measurements like what you are seeing. Let me stop that here. So what I have E1, which is equal to 212, E2, which is equal to 211.9, approximately they are similar because I'm measuring V line, which is the same like V phase across these two. And this current is I line, and this current is I phase. Like what you are seeing, I line is not equal to I phase. And this guy is representing the power. The sign for the power is negative because of my connection. If I flip the connection, it will be positive. It doesn't matter right now the sign, because I know if I flipped, it will give me positive value. This is P. It is 39. And E3 is the voltage across the resistor, and E4 is the voltage across the inductor, and this is the power factor. The next step is I would like to find S. So I will make change to this guy. See here the voltage. It is approximately the same. I can say it is approximately the same. It is changing. It is approximately the same. I can keep this one. So the power here is P. I will change it to PQ. Right now I'm measuring the Q in case of single phase, which is 34.5, and then I will change this guy to the S, which is 52. So what I would like you to pay your attention, if I turn the switch on, like what you are seeing, the voltage is approximately the same. So I will take only one shot, like for example, I will keep this value. So the voltage is 212, phase and line. The current, which is line 0.422, the phase 0.246, the power, which is S52, and VR 146, and VL 140, and the power factor 0.75. Then I will change, and I will find the P. P actually is approximately equal to 39.11. Then I would like to measure Q. So I will flip this guy, and then I will measure Q. Q is 36. This is what is needed for that part of the lab. I will show you for the next part, which is part B, how to connect star connection and do the same for balanced system. Bye for now, and I'll see you later for the next.